Hey guys, and welcome to Functional Print Friday. So on the bench this week, I've got a Fluke multimeter, and it's a pretty old one. This is a Fluke model 8020B. This is actually the second multimeter that Fluke ever released as a handheld. The 8020A came before this one, and that came out in 1977. I think the 8020B was released in 1979. It's been a little while since I looked it up. I got this at an estate sale a while back. And of course I read all about it when I got it because it just seemed really interesting. I know Fluke makes really nice equipment. In fact, if I set this guy down, here's a Fluke 117. This is the actual multimeter that I use on my electronics bench. You can see they're really not that different. The form factor is pretty much the same. I mean, yeah, we could manufacture a multimeter a lot smaller than this guy today. I could probably fit one on my pinky fingernail. But, you know, this is about the form factor that you would want to work with for a multimeter. So it's interesting to see that from pretty much the first model, because I think the 8020A basically looked the same as this, that they really haven't changed that much. So if I flip this guy over, you can see right away why we're here today. This guy's missing the battery door. Like, you know, so many things you pick up at an estate sale or a yard sale, they're either broken or they're missing parts, at least when they're this old anyway. And there was no battery in here when I bought it. I didn't even know if it worked, but I picked up this and a whole stack of other stuff for like 10 bucks. So I probably paid $1 for this guy. So I wasn't worried about it. Figured for $1 it'd look neat sitting on a shelf somewhere. But it does actually work. If I flip this on, you see the, oops, was I in frame there? I'll flip it on again. It takes a second for the numbers to stabilize. There's probably like a voltage reference circuit, I'm guessing, that this is measuring against. And the numbers do bounce around a little bit when you first turn it on, but it stabilizes and seems to sit there at 0. It took me a couple seconds to figure out how to operate this guy. You see there's like pictures here of whether the button is in the out position or in the in position. And you basically set all your different options by adjusting those. So like right now we're in DC. If I push it in, now we'll be in the AC range. Same thing with your voltage ranges. If we're measuring voltage, right now we're in the 20 volt range. If we wanted to be in the 2 volt range, I'd hit that one, and that in these couple here are kind of connected together, so that if I push this one, it's going to depress this one. And now we're back to the 20 volt range. So one of the first things I did when I got this was, you know, connect it to my lab power supply just to see if it still works. And I think I set the power supply at 5 volts, and this showed about 5 volts. And I thought, that's kind of impressive. Because on the back, I did notice when I picked it up, I don't know what year this was manufactured. These came out in 1979. I'm sure they produced them for a couple of years. But there's a calibration sticker here on the back. This was actually last calibrated March of 1995. It was due again for calibration in 1997. So if it was ever calibrated again after that, it wasn't done by you know, a licensed place that would actually put another calibration sticker on it. To be fair, I don't know when the last time this was actually used, but I'm anticipating that it's probably not, you know, sometime in the recent past. This was probably in somebody's, you know, pile of things that they didn't want to get rid of, but I can't imagine they were still using it. But I thought, I wonder how accurate it is. So I actually have a precision voltage reference. This has a couple different settings here. If I flip this guy on, it'll output 2.5 volts, 5 volts, 7.5 volts, and 10 volts. And this is just a cheapy Chinese one, but they do at least claim to have measured the voltage reference points on this with some, you know, pricey Agilent calibrated multimeter, and then they wrote the actual values that this guy outputs at the different settings here out to, it looks like 1, 2, 3, 4, 5 digits to the right of the decimal point. So if we trust that, we know exactly what voltage is really coming out of this guy at these settings, and that's the whole point, right? I think we can, you know, trust it to some extent. Anyway, I wouldn't be sending stuff into space counting on this being 2.49905 volts, but I mean, hey, I'm just a guy messing around in my garage. So let's try the newer Fluke meter first. I think this goes out to 2 digits in the range that we're going to see for 2.5 volts. Oh, 3 digits actually. And that matches up, so 2.499. And if we flip to the 5 volt range, we We see 5.002, and this says 5.003. So this guy's off a little bit, but probably within the margin of error that this scope is rated for. Up to 7.50. Now we only get 2 digits to the right of the decimal point on this one, and this says 7.501. So yep, that is in spec. And at 10 volts, we are at 10.00. I think that's a 501. So if that is a 5, I guess 10.00 or 10.01 would be acceptable there. So this guy's in spec. That's what I would expect. I mean, this is probably 5 or 6 years old, but yeah, it doesn't get bounced around. It pretty much just lives in the cabinet above my electronics bench. So let's get this out of here. Let's try this guy. And again, the last time I believe this was calibrated would have been 1995. Manufactured sometime, let's call it around 1980. I'll get some glare there on the screen here. I'll hold it up. So let's see, we are in, I should have checked the range before I plugged that in. We're in the 20 volt range. Okay, we're okay. Wow, 10.00. And again, this is 10.005. We got the same reading. Oh, actually, this one's flipping to 0.1. Wow, now that I said that, I kind of bounced around all over the place. That might be me moving it around, causing something to oscillate in here. Let me just set it down on that. Yeah, you guys can see the screen. Okay, so it looks like it's right on 10.00. That's where we'd expect it to be. See, do we need to change the range? Let's go down to, we'll go the other direction on this guy. So 7.5, 7.50, and we can't go down in the range here yet. Actually, we're going to have to use the 20 volt range on this guy for all these, because the lowest voltage we're going to go down to is 2.5 volts, so we'd be over on the 2 range. At 5 volts, we are at 5.00. And we are at 5.00 here on our calibrated voltage reference. The 2.5 should read 2.49 though. So let's see. Well, it's flipping back and forth. But it is 2.499. So yeah, I guess actually, yeah, that's if it's rounding that digit, it really should be 2.50. But it is flipping back and forth, so it's kind of like it can tell that it's really close. So there we go, and I've done nothing. I imagine it's probably not impossible to calibrate these on your own, but I have not opened this guy up. That is just as I found it off this lawn at a garage sale a couple years back. So I thought that was really impressive. You know, I just remembered that I had picked this up many years ago at another estate sale. This is, well, it has a label that is really hard to read. This says some sort of identification number. I don't know what that means. Calibration interval, 180 days. Authority? I'm not sure what that means. Calibrated for, I think that says 20 ranges. Date due, July 21st, 1963. Yeah, so I don't know when this was manufactured, but this is quite a bit older. If you guys are into old multimeters, I just picked this up because I thought it looked really cool, and it was also really cheap. I didn't pick this up with any intention of actually using it as a multimeter. I picked it up just as a, as a curiosity to put on a shelf. Let's see if I can actually get this in frame. And I've never tested this guy. I just went and grabbed this because shooting this video, I thought, I wonder if that other one I grabbed does anything at all. And I actually don't even know how to use this. It actually has 2 AC ranges, 300 volts AC, 600 volts AC, 50 volts DC, 500 volts DC. And then I don't know what these things do, nor do I know what this does. And I'm assuming this is just measuring resistance over here. So if we switch this guy into 50 volts DC, hey, let me know down in the comments if you guys know what this thing actually is. This says Selson Zeroing Analyzer. Made by Rollersmith, property U.S. government. Well, I didn't steal it from the U.S. government. I bought it at an estate sale. But I don't know what that means, cell-send zeroing analyzer. If you guys do, let me know down in the comments what this thing was originally intended to do, because it's also got like a second set of inputs up here at the top. 115 volts AC, 400 cycles, and it says zeroing. Rollersmith was in Bethlehem, Pennsylvania. I'm like 20 minutes from there. So maybe that's why I found it in this area. I don't know. Maybe somebody that manufactured these had it. Maybe this one never did go to the U.S. government. I don't know. I have no history on this guy. So, but I thought you guys might be interested in it. I've got you guys pretty much in line with the actual meter here on the front of this panel. So that should give us a fair shot at seeing what this guy's really reading. So we'll set our voltage reference to, let's see, our two ranges here are 50 volts DC and 500 volts DC. So I think to be fair, we probably ought to set this guy at 10 volts. And this does not have any place to plug in banana plugs like this, but we'll just touch them to these terminals. Well, is that right on 10 volts? Can't really see it from my angle. Got you guys in the way. It's pretty darn close to 10 volts. I'd say it's probably reading about yeah, it's actually probably reading about 9.5. So I guess all things considered, it's not, it's nowhere near as close as the other ones. But if we consider the fact that this has not been calibrated since the 60s, and we're also on a 50 volt DC range, that's pretty impressive. You know what? Let me grab my lab power supply and set this up with a higher voltage and just see how close it is higher in the range. All right, so I've got this lab power supply set at 32 volts, and this guy's probably not that accurate, but I just wanted to get something that's higher in the voltage range just to see what this actually reads it as, since we are in a 50 volt DC range. And wow, that's okay. So that's actually right on 32 volts. All right, well, that was a really fun distraction for me, playing with those other toys, but we're here for a functional print, so let me show you what I came up with from a design perspective for the battery door for this guy. All right, and here is the design for this, and what I did is I looked up actually a picture of what the back of one of these multimeters looks like, and I found a fairly high resolution picture that was posted to Reddit, where I could clearly see what text was on the back of here, and these sort of little arrow things showing the direction that you slide this to open it in. And it also gave me just kind of an idea of, you know, how the fit was supposed to look against the multimeter, you know, sort of how curved this edge was here. And I think I got it pretty darn close. This is actually done in two different parts, because this is the face here that goes down against the print bed. And that is so that we can get these features here, the text to come out clean, and then most importantly, the feature of the sort of little clip that comes in here that springs a little bit to lock into the multimeter, which means this piece here, which actually fits roughly over this section here, wouldn't print very cleanly. So I did that as a separate part, and we just need to print two of these dowel pins as well that go into these recesses here, which then go into the recesses on the bottom of this piece. So that is actually printed separately. So if you download the STL for this, inside the zip file will be the main piece, this piece here, and then you'll need to print two of these dowel pins in here as well. And you can cut out some foam rubber, or I just made TPU pieces. They're not in the design file here for these recesses here. They should really be rubber. TPU, you know, works okay, but if you've got like a rubber sheet that you could cut up with an adhesive back to put into these recesses here, and then just replace the ones on the other end of the bottom of the multimeter as well, so that they match. So, all right, let's go see how this fits. All right, back down here at the bench, here is the actual print, and it came out pretty nice. The lettering is a little bit hard to read. If this was a resin print, it probably would have come out even crisper on the lettering back here, but it looks good. I can definitely read what it says. And I think it is pretty true to the original, just based on the photograph that I had found of what this battery door is supposed to look like. The feet, being in TPU, they're okay. They're not, they're not the same rubber that I would have expected to be on here when this guy was new, but I do like the contrast and color, and I mean, I could push it with my fingernail. It does have some softness to it, but not like the actual rubber that probably would have been there originally. I should try some other durometers of TPU. I've only ever bought the SaneSmart TPU stuff because I've been so happy with how it's performed, but I should try some different durometers, softer TPU, and just see how well it works. Comment below what you guys are using if you want to make another suggestion of something else to try. So let's see how this guy fits on here. There we go, and it clicks in really nice. Follows the same profile as the multimeter and locks in nicely around all of the edges. And actually where it locks in, so you can see here, this guy is not coming out on its own. You've got to push it, and what that is doing is unlocking this piece right here. Certainly the color is way off. I don't know of a filament that's actually this color, and I don't know how well this is coming across on video. If you have a suggestion for matching this or something that might be close, let me know down in the comments. It's sort of like that just sort of generic yellowed, discolored plastic. So guys, as always, thanks for hanging out with me in the shop this week for this design and the distractions that we got into. I had a good time, hope you guys did too. And I hope this video finds somebody that's got the same multimeter and is maybe looking for a replacement battery door for it. I think this will fit the 8020A as well. This is the 8020B, but I think the actual case itself is the same between those two multimeters. So it should fit either one, and I think the lettering is the same between the two as well. So if you're watching this video looking for this file, this as well as all of the things that I do on this channel, all the designs that I do, I give the STLs away totally for free. They are linked down below in the description on my site, fpfdesigns.com. If you enjoyed this video, I do a new video like this every single Friday where I either fix something, often design totally new stuff that performs some function around the house or out here in the shop. Always give the files away for free. So if you're into that, hit that subscribe button. And guys, if you do, I'll see you next Friday.